In 1971, a consortium of West German aviation companies rolled out a jet airliner that defied a century of aerodynamic convention. It had a cruising speed of 450 miles per hour. It carried 40 passengers, and it mounted its jet engines directly on top of the wings. It was the first commercial airliner built in Germany since the Second World War. Within 6 years, the production line was dead. The government had pulled the plug, and the program had burned through hundreds of millions of dollars. To understand why the VFW-Fokker 614 was built, and why its failure was so absolute, you need to understand what commercial aviation looked like in the late 1960s. The jet age was dividing the world. In the United States and Europe, passengers were crossing continents in massive Boeing 707s and Douglas DC-8s. The infrastructure to support them, long paved runways, specialized baggage loaders, heavy ground tugs, was becoming the standard. But if you needed to reach the developing world, regional hubs in Africa, South America, or isolated parts of Europe, you were still flying on propeller planes from the 1940s. The new jets demanded pristine concrete. If you took a traditional jet with engines hung under the wings and landed it on a dirt or gravel strip, the low-hanging turbines acted like giant vacuum cleaners. They would ingest rocks and destroy their own blades in seconds. The transition to jets had a geographical limit. West Germany had been locked out of the commercial aviation market for decades. They wanted back in, but they knew they could not compete with Boeing on long-haul routes. Instead, they looked at that geographical limit, and they decided to build an aircraft that could cross it. In 1961, German engineers, later partnering with the Dutch manufacturer Fokker, began designing the VFW-614. Every design decision in it attacked a documented problem of operating in remote environments. The core of the design was the overwing engine mount. By placing the engines on top of the wings, the engineers solved the foreign object damage problem entirely. The aircraft was immune to dirt runways. Because the engines were out of the way, the aircraft could sit incredibly low to the ground. The landing gear was short and rugged. Passengers could board using built-in air stairs. The aircraft required no external power carts or specialized ground crew. It was designed to land in the middle of nowhere, turn around, and leave. It was a brilliant engineering solution to a massive infrastructure problem. By the way, if you are into stories like this, subscribing takes 2 seconds, and there is a lot more coming. On paper, the VFW-614 was precisely what the developing world needed, but aircraft are not sold on paper. They are sold on balance sheets. And this is where the engineers fundamentally misunderstood the market they were trying to serve. Mounting engines over the wings was not as simple as moving them up. It required complex structural reinforcements to manage exhaust heat and aerodynamic stress. The consortium had to commission a brand new, highly specialized turbofan engine from Rolls-Royce and the French company Snecma, known as the M45H. In early 1971, just months before the prototype was scheduled to fly, Rolls-Royce went into receivership. The company was bankrupt. The British government had to step in and nationalize it to save the engine program. The delays were massive, and the development costs skyrocketed. What was supposed to be an affordable, rugged regional jet was rapidly becoming an incredibly expensive piece of custom European engineering. When the sales team pitched the aircraft to regional airlines in developing nations, the response was immediate. The airlines loved the capability, but they could not afford the price tag. The very customers the plane was built for walked away. They opted for turboprops, like the Fokker F-27 instead. They were slower, but they could land on the same dirt runways for a fraction of the cost. With their primary market gone, the consortium desperately tried to pivot. They pitched the 614 to regional carriers in Europe, and even embarked on a massive sales tour in the United States. But here, the aircraft collided with a different reality. Western airports had paved runways. The overwing engines were solving a problem that did not exist in Paris or Chicago. What mattered in the West was speed, capacity, and comfort. The VFW-614 failed on all three counts. It was slower than a Boeing 737, it held fewer passengers, but the most glaring issue was the cabin experience. The same engineers who brilliantly protected the engines from ground debris failed to account for what happens when you mount a massive turbine directly against a wing root. The noise and vibration did not dissipate into the open air. They transferred directly into the passenger cabin structure. For anyone sitting in the middle of the aircraft, the roar of the Rolls-Royce engines was deafening. The program was already struggling when tragedy struck. On February 1st, 1972, the first prototype suffered severe elevator flutter during a test flight over Bremen. The violent vibrations forced the crew to bail out, and tragically, one pilot did not survive. The crash delayed certification by a year and shattered buyer confidence. By the time the aircraft entered service in 1975, the aviation world had shifted. The 1973 oil crisis had decimated airline budgets. No one wanted a custom, expensive regional jet. Only 3 airlines ever bought it, ordering just 10 aircraft. In 1977, the West German government finally pulled the funding. The production line stopped at just 19 airframes. For decades, the VFW Fokker 614's failure was seen as definitive proof that overwing engines were an evolutionary dead end. The aviation community concluded the design was simply wrong. But the passage of time proved the German engineers were not wrong. They were just early. Decades later, Honda Aircraft introduced the Honda Jet, a wildly successful aircraft utilizing the exact same overwing engine mount. Honda used it to reduce high-speed drag and maximize space, proving the aerodynamics were fundamentally sound. The VFW Fokker 614 was not bad engineering. It was a machine built to answer a question the developing world could not afford to ask, and the developed world did not need answered.